Alright, so remember in the first 6 weeks we talked about conditional statements, and we had this statement: if you pass the test, then you will pass the class. What is the converse? The converse, remember that it is the flipped version. So if I started off with if you pass the test, and then I went into you will pass the class, the converse would be if you pass the class, then you pass the test. So all I did was change the order. This is something we went over in the first 6 weeks. Remember that a perpendicular bisector is a line, segment, or ray that is perpendicular to the segment at its midpoint, therefore bisecting the segment into two congruent segments. Now we want you to discuss what this means in your own words with your neighbor or your group. I'm going to translate that for you because I know that's a lot to take in. So it says a line, segment, or ray that is perpendicular. What that means is if I have a triangle, you have to know what the word perpendicular means, you have to know what the line, segment, or ray, and you have to know what a midpoint is. So what I do is I go to this side, I find the midpoint, and I know I'm going to have a line that is perpendicular to this side of the triangle. So it looks like that. Perpendicular. Then I do the same thing on this side, where I know I have a line that is in the middle, and so if this is a midpoint, then I draw a line that is perpendicular to this. Looks maybe something like this. And if I have a midpoint of this side and the line that is perpendicular to it, then it looks something like this. Now I know it's not perfect. I know it's not perfect, but that's conceptually what it is. What do you notice? Well, remember we said it's the midpoint, so this would be a midpoint, and this is a midpoint, and that's the midpoint. And wherever they cross, it's hard to do on a little airliner, but this is supposed to be perpendicular. This is supposed to be perpendicular, and they cross outside the triangle. Now, a perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. What that means is if I sit on top of this perpendicular bisector, then I am the same distance away from the vertices. See how these are the same distance from the vertices? And this is going to be the same distance from the vertices. The converse of the perpendicular bisector theorem: if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. That's the original. This is the converse. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. We don't have time for that. Practice example. Given CD is perpendicular bisector of AB, find CA and DB. Explaining your answer. Well, bit by bit, if we have a triangle here, right, and we know this is a perpendicular bisector, then we know if we sit anywhere on this line, then this 5 right here should be the same distance here. And then if this is 6, then this one should also be 6. Let's check our answer, and we're right. An angle bisector is a ray that divides an angle into two congruent coplanar angles. Translation: so if I have a triangle, looks like this, an angle bisectors from the vertices and divides this angle in half, or into two equal segments. Here, I divide this angle into 2 equal segments. So this should be equal to that, and same thing here. Okay. What do you notice? Well, this right here is 10, and I'm almost positive from here to here is 10. So what does this mean? If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So remember, this is the same distance here. Doesn't that make sense? If this was a triangle, right? And we know that this angle is equal to this angle, so that means this angle is across from this side. This side has to be congruent to this side. If a point is in the bisector of an angle, then the point is equidistant from the sides of the angle. Then the converse is, if a point is in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. So if we want to find the length of FD, FD is here, that's 2x plus 24, BF is 5x. We want to find out what is this distance. First, I need to find x. And in order to find x, I have to find a relationship between this and this. It says F is on the bisector of ACE. So if I'm sitting on this line, then I'm equal distance from each side, which means that this is equal to this. So I'm going to set them equal to each other. I'm going to solve for x by subtracting 2x. Then I'm going to divide by 3, and x is 8. But I'm not done. If I know x is 8, I substitute. 2 times 8 is 16, plus 24 gives me 40. All done.